Hello, my name is Harry Grill, and I'm your host today for this workshop on high-performance computing. Today, we're going to have an explanation about what actually is high-performance computing. Then we're going to talk about the EuroCC initiative that is active in 33 countries. And then we're going to have 3 example countries, namely Germany, Czech Republic, and Austria, and show you what these is done in these countries. Now I'll hand over to Marcus, who will explain you the HPC and the EuroCC initiative. Thank you.
So thank you, Harald. I will give a general overview, as Harald said, and just to motivate where we are coming from. So in EuroCC, most entities that are participating have a background in scientific computing, and so researchers from universities or similar institutions, and when they do simulations to find out certain things, they usually use they start, for example, with single server or local machines where they are doing their simulations, and of course you know all that they have machines with CPU, memory, hard disk, and probably an accelerator, and use that to solve their problems. And there might be at one point the situation that you have this machine under full load for a lot of time, or basically overtime, and when you want to go further, you have to use bigger machines, and this is where we are dealing with usually. So we are working with so-called supercomputers, so large clusters of servers, and compared to the picture before, we're adding a fast network, which is from the technology point of view most of the time InfiniBand or maybe other technologies, and we're building up these clusters to run large simulations. If you do that, you have to take into account that the memory is distributed, so you have to find certain programming models, or basically think about how you run your simulations on such machines. So we from the scientific background, we're dealing for a lot of time with that programming models, and using, for example, MPI and OpenMP to do the intranode and internode communications. The clusters, you might have heard about that, range, if you go to smaller institutions at universities, to some tens of compute nodes, and might go up to several thousands if you go to the large sites in Europe, for example. And EuroCC is now built around these centers, and I will come later to the specific tasks, but we have this background and try to address now in special industry and SMEs and so on. What we have seen in the past is what I would call here classical workload. This is what, for example, physicists have a lot of cases. So you run simulations that are heavily bound to CPU and memory, and probably network. So you do the simulations and communication on the machine and in between the compute nodes is important. In the last 10-15 years or so, we've seen a change. So we also see, for example, big data workloads. These are I/O bound. So in this situation, we have the data, for example, residing on single servers, and you're doing, for example, MapReduce on that, and this includes also a good network infrastructure. If you look at this a little bit in more detail, it could also be that the data could be delivered via parallel file systems from the network, but nevertheless there are workloads that are heavily I/O bound. Then this is what I classified as AI workload. So these guys usually like to use GPUs to train AI models and do machine learning and so on. And sometimes they need access to data, which is important as input or output, for example. And as far as I can see, at least in Austria, it's often that these setups use GPUs on single machines, and they do not do communication with between several servers usually. So it's either not implemented yet, or there's a principal algorithmic obstacle that prevents doing that. If you look at this from the scientific domains view, in let's say 20, 30, or even more years ago, it was mainly the used such systems were used by natural sciences and engineering. And if you proceed in time, we see, for example, bioinformatics as a new strong user base, and data science in general, but also other disciplines like economics and humanities, for example, in general, have a demand for using such system to solve specific problems. So in the academics, we see that high performance computing and data analytics and so on has a strong, let's say, footprint, and we see growing demand for that. And why we are here now is that there is the so-called Euro HPC joint undertaking, which is funded by the European Commission, 32 countries, which are not all in the EU, and some other private initiatives. And this Euro HPC undertaking is the aim is to support HPC, big data, and AI in all over Europe for all people who might need it. And this is done by different means. For example, there can be grants, so funding for certain things where individuals or companies can apply for. There's then this European Processor Initiative to develop a European processor for computers, and this might eventually lead to supercomputers which use this technology to be somehow independent from Asia or America a little bit. And the goal is to build really large supercomputers that can be used by academia, but as well as industry, and also industry is always including small and medium enterprises. One other task, or one other thing from the joint undertaking, is to build these national competence centers. This is what EuroCC is actually. So we are building up these competence centers to be a point of contact in each country regarding HPC. What is also happening right now, there might be a HPC master program that is under design to foster and increase the knowledge in this area. EuroCC by itself has the mission, as I said, to build up these competence centers. You can see the map, which countries are on board, and the target audience is, as I mentioned before, academia, but also public administration, industry, and small medium enterprises. And what we try to do is we try to offer all of these audience a certain kind of services and input that they can use these technologies. So we, on the one hand, try to improve the knowledge level by offering trainings and improve the skills in the countries. We also try to tackle or foster the collaboration with industry, startups, and so on. So we go to them, talk to them, try to find out what they need, and try to improve the situation. We can help if people have a certain problem. They can come to us and ask us, how would you solve it? We can help them, to look at that and maybe find partners who can help with the problem, either in the country or by our European network. And also we try to do some kind of community building to bring the people together from the different point of views or different knowledge levels to start exchange and collaborations or whatsoever. Yeah? So finally, so in the end, we would like to be a national point of contact where people who are interested or have problems with HPC, big data, and AI, so that they can come to us and we can help them to find the right solution for their problem. And we hope that this project has started in last September, that this will be a well-established point of contact in each country, and then that you can help to make use of these HPC machines and so on in whole Europe, to make this very important technology usable for the broad public, I would say. So this is basically all I have to say here. Just a few links to the joint undertaking, to this EuroCC project, and the partners which are talking today. And that's basically all I wanted to say. And I would like to hand over to Andreas Wirse or maybe Harald in between. So thank you for your attention. And I'm open to questions either now or during this event, if you like. Thank you.
Yeah, I guess I can take over now. My name is Andreas Wirse from Zikos BW, and we are a partner in EuroCC. And I will let you briefly know what it is that we are doing in work package 2 in Germany. And on the slides right now, you see the partners in this work package. So starting on the top left, we have the Leibniz Rechenzentrum in Munich, in Bavaria. We have the Jülich Supercomputing Center at the Jülich Forschungszentrum in the west of Germany, and we have the High Performance Computing Center, HLRS, in Stuttgart. So those are the three federal German computing centers, so the tier 0, the top level. We also have as a coordinating partner the Gauss Center for Supercomputing. Actually, the three computing centers I just mentioned are, let's say, part of this Gauss Center. So this is the overall center for these, which is also leading this work package. And then there's Zikos BW. We are actually a kind of daughter company of the University of Stuttgart. We are closely related to HLRS, and our job is industry relations, which we do since almost 10 years. Our anniversary will be in June. And you've heard from Markus, there are, well, supercomputers involved, big ones. So I just show you the three that the three computing centers are operating, or well, they're operating more than those three, but those are the biggest ones. So starting on the top in Jülich, we have the Joules booster module, which is on the number 7 in the top 500 list. With very strong graphics cards in there. We have SuperMUC new generation, next generation in Munich, currently on number 15. And in Stuttgart, we have very right following SuperMUC, we have Hawk, installed about a year ago with 20.25 petaflops, where the focus is a little bit stronger on the engineering side, on the industry. Talking about industry, a strong part is really that we want in EuroCC, we want to transfer knowledge from the computing centers towards industry, support industry in making use of these systems. And what you see on the screen right now is actually it's well, a lot of logos, but the idea behind those logos is those are all more or less associations where we from Zikos work with industry. So on the left side, you see the column that's all chambers of commerce in our area. So in our focus area is Baden-Württemberg at Zikos BW. But the other logos, they are very, very different. There are IT associations, there are manufacturing partners. We have economic support groups in there. And that's a very, very important message. If you want to transfer towards the industry, you have to reach them, and then it's not so easy to make them come to you. So you have to really go out, and networking is a very, very intensive part of our work. And what also helps a lot to convince others to use HPC are success stories. And just as an example, I've brought one success story with me, which I think is pretty nice. The company Optima Pharma, not very far, about an hour drive from Stuttgart. It's, let's say, a large SME or a mid-cap, as the EU puts it. They have about 500, 550 employees, and they are focusing on filling and packaging technology. And the image that you see is actually a CAD image with some fluid flow. The blue lines and balls are particles, air particles flowing around of such a packaging machine. In the pharma business, everything needs to be very, very clean. So this is what you see is the simulation of the airflow in such a clean room environment. And in order to have a really good working setup, in the past, they did some planning at Optima Pharma, and then they built the system and constructed it at the customer side. And when it was fired up the first time, they were not really sure how it would work. Of course, they planned it properly, but they tried it out, and when it stood there, they found, oh, we probably should change something here or there. And they did that, and it usually took about 6 weeks from the switch on until the system was really operational. And this was a long time where the customer had to wait for this. And there was an engineer coming freshly from the university who said, well, why don't we do a numerical simulation about that beforehand? So before we build up the system. And he convinced his bosses to support him. He first tried to do it with a commercial code, but that didn't work out really as they thought it would. So he went back to the university, actually to HLS in Stuttgart, and together they set up an open foam-based solution. So the computers that are used for these simulations are actually right now, it's Hawk. There's also a strong visualization component. So we have a 3D virtual reality environment where the people from Optima Pharma really can come and take a 3D view on their solutions, on their simulations. And well, of course, it's a success story. I wouldn't tell it if it were otherwise, but this really worked very, very well. And a while ago, the first time they went to a customer, set up their system, they switched it on, and it worked as planned from the first second. And if you think of 6 weeks of operation time, this is a lot of money for the customer, but also for Optima Pharma. So HPC really brought a big advantage to both of them. So this is the kind of success stories that we are building, collecting, and sharing so that others see that HPC really is a great thing to do. And the other thing, of course, is if you decide as a company to go into HPC, into simulation, you probably also need some proper training. And in an ESF-funded project, we developed the Supercomputing Academy in Stuttgart, and you see there are several courses that are available. You can dig into simulation, how it works. You can learn about simulation, but there's also economics and sustainability in HPC. And that's also, we see us in a way as a one-stop shop. So EuroCC, the national competence centers, they are able to provide everything around HPC, from the computer to experience, consulting, and up to training, so that we will be able to really support industry as good as possible, and especially the smaller ones, the SMEs. So that's it from my side, and now I hand back to Harald.
Well, thank you, Andreas. Now I'll take the floor, if I may. I can. Now you will see the example of Austria and what we are doing at EuroCC, and how that we are a little bit smaller than Germany, let's call it that way, but we are more partners. In Austria, we have 5 universities that are covering that are the project partners of EuroCC. It's University of Vienna, Technical University of Vienna, the University of Life Sciences and Natural Resources, the Technical University of Graz, and the University of Innsbruck. But as this is only universities, we also need special, let's say, cooperations within certain areas, and we found that we did not have any connection to the startup community, and that's why we also have INITS as an incubator to be able to also communicate and help the startup community here in Austria. Basically, these universities also cooperate with to the Vienna Scientific Clusters cluster, and the Vienna Scientific Cluster is the supercomputer here in Austria. But Austria is small, but it has a lot of HPC smaller infrastructures. As you can see here at EuroCC, and the network is also about using not the only the infrastructures that you own by yourself, but also to map the others and also point to the other infrastructures that are there and to the competences actually that are there. Because, for instance, yes, okay, the Vienna Scientific Cluster 4 is by far the most powerful, but if anybody needs some simulation concerning fire and fire extinguishing and so on, we provide them the contacts from there, or climate change or visual computing and so on and so forth. So EuroCC is not only about the project partners, but also the whole HPC ecosystem. And now I want to demystify a little bit of what an HPC system and infrastructure actually is. As you saw from Andreas, the really big ones, the Vienna Scientific Cluster is by far not that powerful compared to the other 3 that Andreas recently mentioned, but it fits in a, let's say, larger room. But what HPC systems differ from, let's say, your normal racks in your normal IT infrastructure, it's fully packed and there is a lot of heat in there, and you need to get rid of the heat. So here you see on the right hand side that it's fully packed, and that the water cooling system here are the arrows that go down. Yeah, so this is an HPC infrastructure that we actually here have in Austria. It's smaller but also very powerful, and for most of the things that industry needs, it's by far large enough to cope with everything that comes. What we are doing here in Austria, and we'll present you some recent success stories. For instance, the company Tailsit is really a small company. It has 3 full-time equivalents, and Tailsit is a developer of software simulation. And they have their software, and this software runs on a single CPU. It's shared memory, but their simulations really take a long time if it gets complex. And as the customers demand more, they don't want to wait a long time for the results, so they came to us, and we help them. We offer them now the access to our infrastructure, basically to the Vienna Scientific Cluster, and go together with the customer into their code and parallelize their code and transform the code from a shared memory to a distributed memory code. And this, all in all, brings them distributed memory parallelization. And with this parallelization, they get a large reduction of computing time and increase in software efficiency. And in the end, happy customers, because the customers get their results very fast and don't have to wait for several weeks, but only several hours. And I now want to go some, let's say, buzzwords, because there is a lot of buzzwording now today with, let's say, Internet of Things, industrial Internet of Things, and so on and so forth. And I want to take here now the example of a digital twin. And normally, what people think about, or what used to be, is HPC is on the left-hand side, so computer-aided engineering, finite elemente, fluid dynamics, and so on and so forth. So if you have something complex, like this propeller here with a nozzle, and you have to optimize it, your normal PC cannot cope with the calculation. What is now upcoming, and we have here several, let's say, customers in that area. But what is now also upcoming is real-time performance, for instance, in monitoring complex machine parks or time series analysis in the energy sector. So the data that you get from your physical assets, they start to send data, and somebody has to make value out of the data, and you don't. The value doesn't lie in a prediction what happened, but what will happen in the future. And this is, in some cases, very, very computing intensive. And these are the things that we actually do here in Austria to service the SMEs here. And now I will stop and hand over to Thomas, that he presents you what actually the Czech Republic is doing in EuroCC. Thank you.
You muted, Tomasz.
Thomas, we can't hear you. Unmute yourself.
Okay, now it's better, but I have to start my presentation. So sorry for that. Too many windows, too many things. So one more time, my name is Tomasz Karasek. I'm from the Czech Republic, and I'm representing the National Center of Competence in HPC. And I'm also from IT for Innovations, which is the National Supercomputing Center in the Czech Republic. In the EuroCC project, we are the only one partner, because we are the only HPC center in the Czech Republic. Our mission is to provide the access to the knowledge and to the HPC infrastructures to the stakeholders from the Czech Republic, and our vision is to be a single point of the contact, not only for the HPC, but also for the associated technologies like HPDA and AI. So basically, what we have here in Czech Republic, we have the HPC infrastructure, which is the hardware. Currently, we run 3 supercomputers. The biggest one is the petascale system called Carolina, which is installed right now and should be in the full production really soon. The second one is the Barbora, which is our smaller system installed in the last year, and the last one is the specialized system for the AI, which is the DGX2 from the NVIDIA, full of GPU accelerated cards, and is used mainly for the AI applications. So as I mentioned, our goal is basically to provide the access not only to the hardware, but most importantly to the expertise, because not everybody is the expert on the HPC. And for all of us, I believe in the EuroCC project, basically the hardware or HPC infrastructure is the tool which we use for the work, as you heard, the digital twin, numerical modeling and simulations, etc. And that's exactly our approach. So basically, what we are combining is numerical simulations, artificial intelligence, and the big data. Because when you run the numerical simulations, you on the HPC, you create a lot of data, and then you have to post-process it, visualize it, etc. And this expertise we are developing here in IT for Innovations. We are providing the research and development in the academia, to the society in the broader sense, and to the industry. I also prepared some examples how we are doing it. So basically, our past success stories are around the virtual prototyping, because I don't want to use the digital twin. Not that we are not working on the digital twin as well, but sometimes this word is overused, and sometimes the virtual prototyping is the better fit. So we work with the manufacturing companies who are manufacturing some products like biomedical devices on the right, or passenger seats for the trains on the left. And those companies usually work in the old-fashioned way, where the designers design their product, they build the prototype, and then the prototype is tested, and feedback from this testing is passed to the designer as it's changed. And as we all know, this one is very costly. It takes the time, and computers could help to reduce this time. And because those simulations are really complex, and you have to encounter for many things and many variables and many changes, the supercomputing is basically a necessity, because on your laptop or a desktop PC, those calculations would take days or weeks. And when you're talking about the optimization and changing some properties, it could take a month or even a year just to run one successful simulation or set of simulations. So the supercomputers are basically a necessity, and that's what we are doing. We are providing not only the hardware, but also the knowledge of our researchers and engineers. Within the EuroCC project, we are basically playing the role as was mentioned here, providing the training activities, etc., which basically for us it means that we will be in the future linked to the European Digital Innovation Hubs. If you follow this initiative, those European Digital Innovation Hubs should start soon, and they should provide the soft competencies to the stakeholders, mainly to the industry and mainly to the SMEs. But combination Digital Innovation Hub and National Supercomputing Center gives a very good sense to us, and we are right now basically discussing with our colleagues who are involved in the preparation of the European Digital Innovation Hubs, how to join our forces together and how to combine our knowledge in the hard skills, which is the advanced computing and simulations, with their skills in the awareness raising, searching for the companies who could join us, organizing the training events, etc. So this is where we combine our forces to bring the added value to the stakeholders in the Czech Republic. And that's all from my side, and I'm ready to take any questions which you would like to ask.
So thank you, Tomasz. Are there any questions? Because I right now checked Slido, and we either seem to bore you, or we explained everything so nicely that you don't have any questions. So if there is anything, please go to Slido and type it in. Thanks. as there's nothing popping, I'll send the. Is there something up popping? Because there are too many windows here. No. I would thank all my co-hosts and presenters for having us this joint talk to you, and thanks also for the organizing team at the Software Days. And if there are no more questions, we can go and have coffee. Thank you.